This is Mr. Precella. We're reviewing for our final exam, and it looks like we are up to some cut point problems. Remember, if you have a inequality to solve, if it says solve and it's something with a less than or a greater than, or there might be an equal to, a greater than or equal to, or less than or equal to, you do the cut point method. Notice the instructions don't say do the cut point method. You've got to know when to do it. You use that cut point method when it says solve and there's a less than or greater than. And it also talks about writing your answer in interval notation. Okay? So let's see, but the cut point method, we start off by finding the solution cut points. Then we find the denominator cut points. The order isn't really significant. If you're a view and example person and you look at the view and example, then they don't necessarily always find the solution before the denominator, but I do. Speaking of denominator cut points, on this problem there are no denominator cut points. Okay? How do I know there aren't any? Well, there's no fractions here. The next two problems I think have some fractions in it, so there'll be denominator cut points there. So we're finding the solution cut point by putting an equal sign in place of the inequality. And this is a quadratic equation, so get a 0 and factor. So I'm subtracting x and adding 2. So we'd have an x squared minus 4x. Is that going to be a minus 12? Equals 0. And if I draw my two sets of parentheses, this one will factor without too much trouble. What makes it easier to factor than sum? The fact that there's just an x squared. There's not a number in front of x squared other than a 1, I suppose. You could always write a 1 there. 1 times 12, 2 times 6, or 3 times 4. Which pair of numbers is it going to do? Or it's going to work. Is it going to be a 2 and 6? We want the 2 and 6 to multiply together to give a negative. So that means we need a positive and a negative. So how do I need to arrange my signs to get a negative 4x? I would need the 2 to be positive and the 6 negative. Okay. And setting each one of those factors to 0. Set x plus 2 to 0, we get negative 2. Set x minus 6 to 0. Move that 6 over. Positive 6. With solution cut points, you look at the symbol up here to decide between open and closed circles. Since there's a equal sign on it, do y'all remember what we're going to have? Open or closed?
Closed.
Closed. So I'll draw my number line. Label negative 2 and positive 6 in numerical order. If you put the 6 over here and the negative 2 here, you're going to get it wrong. And they're closed circles. And I'm just going to test one of those intervals. Okay. As long as there aren't any repeated factors, then it's going to alternate. Okay? If we had gotten the same thing in both sets of parentheses, then it might not alternate if you have a repeated factor. For our purposes, it alternates. So I'm going to test the number 0. Where does 0 lie? Well, it doesn't lie between two negatives. It doesn't lie between two positives. 0 is always between a negative and a positive. So I'm testing 0. So I'm testing that middle interval. And when I do this testing, I'm plugging it into the original problem. Okay? So if I come up here and put a 0 in the original problem, the 0 squared is 0. The 3 times 0 is 0. Minus 14 is greater than or equal. 0 minus 2 would just be a negative 2. Ooh, sometimes students have trouble with the negatives. Negative 14 is greater than or equal to negative 2. It's sure not equal. Is it bigger? No. Negative 14 is not bigger than negative 2. It'd be better to have negative $2 in your account than negative $14. So this is false. So shade. Its solution set negative infinity to negative 2 square bracket union square bracket 6 to infinity. Union just means it's together on the same number line. Now the next one has some fractions in it. Problem number 10. We have a fraction. 5x over x plus 7 is greater than or equal to 0. Oh, let's look back at this. Any questions? All caught up? Let me give y'all a few minutes to catch up. Well, a few seconds. As a child, I remember this show, Truth or Consequences, and they would give these people, ask them these questions and tell them to do stuff, and if the people were good at it and they were getting the answers right, the buzzer kept sounding faster and faster until it was impossible. They'd ask the question or tell them what to do, and the buzzer sounded before they were through reading the questions. And no matter what, they never got to do the truth. They had to do the consequence. So I'm saying that in lieu, I'm giving y'all a few seconds to write it down. Okay? And then I'm moving on. Okay. Here's a fraction, so it's going to have both solution cut points and denominator cut points. So I'll start off. 5x over x plus 7 equals 0. With the solution cut points, you replace the inequality symbol with an equals. And this is actually going to solve really quickly. Why? Well, you can get rid of the fraction by multiplying both sides by x plus 7, which is just going to cancel out those x plus 7s and leave you 5x equals 0. Divide both sides by 5. So we have x equals 0 as our solution cut point. You look up here. There's an greater than, or there's an equal sign on the greater than, so that's going to be a closed circle there. That's the solution cut point. Since there's a fraction, we'll go ahead and find the denominator cut point. With the denominator cut point, the denominator can't be 0. So x can't be, is that going to be a negative 7? Now for the solution cut points, you look up here to decide between open and closed. For the denominator cut points, you don't look at anything. It's just always an open circle. Remember, open circles mean you're not including those numbers as in your solution. You wouldn't want x to ever be negative 7 because that would give you a negative 35 on top and a 0 on the bottom. You try punching that into your calculator, any calculator, it's going to give you an error. You can never have a 0 in the bottom of a fraction. So I'll draw my number line and label 0 and -7. Make sure you're putting them in the correct order on the number line. The -7 should be to the left. Oh, what did I do wrong there? I was just telling y'all it's supposed to be open circle, and I think that looks like I put a closed circle. So, open circle. That's an open circle. Okay. I'll write it out since I messed it up. And a closed. Now, we didn't factor anything here, so this thing's going to alternate. Either true, false, true, or false, true, false. This is, however, one of those where I can't test 0. 0 is a cut point. So, use a number other than 0. Oh, okay. What about 1? Was 1 a cut point? No. So I'm testing 1, which I'm not going to insult y'all by saying the number 1 is between 0 and infinity. You already know that. Okay? So I'm testing the number 1. You can test any number you want other than 0 or -7. Normally I use 0, but this is one of those times where 0 is a cut point. So I'm testing 1. When I test, I put it in the original problem. 5 times 1 is 5. 1 plus 7 is 8. 5 over 8 is greater than or equal to 0. Well, it's sure not equal, but it is greater, right? So, true or false here? What am I going to label it as? True or false? It's true. Okay? So, true, false, true. Then write it in interval notation. Remember, you always put parentheses by infinity symbols. Open circles also have parentheses, and that's an open circle there. In bracket 0, comma, infinity. Okay? The first time I ever saw these, the teacher's method was think about it. And thinking about it, when the number on the right was 0, that was that was easier than when there was something other than 0 over there. Thinking about problem, oh wait, okay, so it doesn't matter. I mean, I did 10, but I haven't done 9 yet. But the actual numbers don't matter. Okay? But I do have another one like this showing you how to do it if there's something other than a 0 right there. Those are a little bit more involved. Any questions here? I'll be uploading these to YouTube later today. And at least on YouTube you can pause me or cut the volume off. Same thing I'm going to do here. I'm going to find the solution cut points, then the denominator cut points. The solution cut points is a little easier when it's just a 0 right there. X minus 5 over x minus 6 equals 3. I'm going to write that as 3 over 1 and cross multiply. We'd have a 3x minus 18 equals x minus 5. Now, I'm going to move this x over here and the 18 over there. So 3x minus 1x, that would be a 2x on the left. Adding 18, negative 5 plus 18, is that a 13? Divide both sides by 2. So it looks like we're getting the fraction 13 over 2, which would be, what, 6.5, if you think of it as a decimal. I wouldn't use a decimal because my math lab generally doesn't like you typing in decimals. Okay? They want an integer or a fraction, but maybe for locating it on the number line, you might want to think of it as 6.5. Now this was the solution cut point. You look up at the symbol. Since there's not an equal sign, there's open circle. Now, one of my pins died. Now, for the denominator cut point, the denominator can't be 0. So x can't be 6. With the denominator cut point, it's always an open circle. Always. So, draw the number line. Sometimes students think they can do this without drawing a number line and testing an interval. And whatever you're doing is wrong, if you think you can do that. Okay, I need to label 13 over 2 and 6. Well, you see the way, if you think of 13 divided by 2 is 6.5, then you see, okay, the 13 over 2 is on the right, the 6 on the left. Both of those are open circles, aren't they? And let's test 0. Or you can test any number other than 6 and 13 over 2. I'm going to test 0. Where does 0 lie? Well, 0 is between a negative and a positive. It can never be between two positives, never be between two negatives. So this is the interval that has the 0. And I plug 0 into the original problem. 0 minus 5 is negative 5. 0 minus 6 is negative 6. So negative 5 over negative 6, that's a 5/6. So is positive 5 over 6 greater than 3? Is that true or false? 5/6, well, 5/6 isn't even 1, is it? What am I thinking this is, true or false?
False.
False, yeah. 5/6 isn't bigger than 3. So false, true, false. Parentheses 6, comma, 13 over 2, parentheses. When you type that in, make sure you don't put the parentheses down in the bottom of the fraction with the 2. As you type in that 2, hit a right arrow to get out of that denominator. Okay. So it's time for us to take another break right now, and we'll pick up with some graphing in a little bit. Okay. So thanks for watching.